So x is equal to this is an oscillating spring, and it follows this rule of x being the distance away from this point here, which you could call the origin. What's the velocity and acceleration? Well, the velocity is dx dt, so differentiate cos 2t. Cos goes to minus sine of something, multiplied by the something differentiated, which is 2. 2 0.2s are 0.4. And the acceleration, differentiate again. Sine goes to cosine of something, multiplied by that something differentiated. So it'll go to cosine 2t, multiplied by that something differentiated, which is 2, which is minus 0.8 then, isn't it? So there's the velocity and acceleration. When is v and a max and min? So v equals, so we'll call it v max, when this sign goes from 1 to minus 1. So v max will be either minus 0.4, or when that's minus 1, it's 0.4. So that would be the maximum velocity, wouldn't it? V min? Well, that would be when sine is plus 1, because it would be minus 0.4 meters per second. Okay, and then the acceleration, or a max. When that's biggest, cos will be minus 1, won't it? Because cos goes from 1 to minus 1. So that makes 0.8 meters per second. And a min, when is acceleration at its lowest? Well, this would be when that's 1, because that would make minus 0.8. Okay, that's max and min. When does that happen? Well, that happens when Vmax. When does Vmax happen? Well, that would happen when sine 2t equals minus 1. Okay, and then Vmin? Vmin happens when sine 2t is 1. Okay, and then also Vmax, Amax. When does that happen? Well, that happens when 0.8 cos 2t equals minus 1, isn't it? And A min would happen when cos 2t is 1. So when do these happen? We'll label this 1, this 2, this 3, and this 4. 4 questions here. So we'll try and work through them if we've got enough time, and then we'll move on to the last question. So when is sine 2t minus 1? CAST. Sine 2t then is negative. Sine is negative here and here. I think as sine is 3 pi over 2. So 2t then will equal 3 pi over 2. So that's when sine is minus 1. It's also, go around again, 7 pi over 2. And then 11 pi over 2. And so on. So t will equal 3 pi over 4. 7 pi over 4. 11 pi over 4. Okay, there's the time for that one. Next one, sine 2t equals 1 would be here. This is number 1. Number 2, pi over 2. And then 5 pi over 2, isn't it? 9 pi over 2. We're just going round in full circles. So t will equal pi over 4, 5 pi over 4, and then 9 pi over 4. Okay, that's that one. And then number 3, cos t equals minus 1. Well, cos is positive here and here, negative there and there, so it equals minus 1 here, doesn't it? So that's pi. So 2t will equal pi, 3 pi, 5 pi, and so on. So t equals pi over 2, 3 pi over 2, 5 pi over 2. And number 4, cos 2t equals 1. Well, that would be here, wouldn't it? Which is at 0. 0 and then 2 pi, and then 4 pi, and then 6 pi. So t will equal 0 pi, 2 pi, 3 pi, and so on. And those are the times when it's max and min. Now the last part of the question says show that d2x by dt squared, which is the acceleration, plus 4x equals 4. So d2 is here, minus 0.8 cos 2t, minus 0.8 cosine 2t, plus 4x. X is 1 plus 0.2. 4x, 1 plus 0.2 cosine 2t. And see what that equals. That's equal to minus 0.8 cosine 2t plus 4 plus 0.8 cosine 2t. These cancel and it equals 4, doesn't it? Which is what we wanted to show.